These are notes for 3.7b, and we're adding and subtracting polynomials, and the denominators are different, so it's kind of a tricky section, one of the harder ones we do. But this is 3.7b, and we're going to be adding and subtracting when the bottoms, or the denominators, are not the same. And that makes it kind of tricky because we have to get that LCD and tweak things. So if you really understand how to add and subtract fractions without any variables, it makes it much easier to understand it when we throw in the variables. So just a little repeat here. I need a common denominator. I need something that contains a 5 and it contains a 4. In this case, that would be 20. It doesn't mean it's always what you get when you multiply them, though. Had I had this, then my common denominator isn't 18, it's 6. So remember, you grab the biggest one and then you keep bumping it up until you get one the other one goes into. So you go 5, 10, 15, 20, and there it is. So this one needs to get multiplied by a 4 to give me 4 over 20. This one needs to get multiplied by a 5 to give me 15 over 20. Once I have a common denominator, I keep it, and I add or subtract the tops, whatever's indicated by the operator in the middle. So that would be 19/20. I always look to reduce at the end, but that one doesn't reduce. On this one, our common denominator, our LCD, is a 6, so I need to write them both over 6. Well, this one already is, so it doesn't need to get tweaked. And that holds when we start doing the algebraic ones also. If you already have the common denominator there, don't mess with the top. But this one needs to get doubled. And this is indicating that I add them, so I keep the bottom and I add the tops. What we need to do now, though, is put that into the algebra realm and start adding a bunch of algebraic fractions, and that's what makes it tricky, but the process won't change. So I have to do quite a few examples in here. Quite a lot of examples would be better grammar. All I have done on this one is introduced an x. So the first thing I need to do is decide on what is my LCD. And that LCD has to contain every single factor that you see on the bottom. It needs to have a 2 in it. It needs to have an x in it. And it needs to have a 3 in it. So my LCD for this one is a 6x. And I do exactly what I did when I didn't have any variables. I'm just going to go pump up those tops using a common denominator of 6x. So this one already has the 2, already has the x, it just needs the 3. So you give it what it doesn't have. And so on the top there I have 5 times 3, which is 15. This one right here has the 3, but doesn't have these. So I need to give it to both the bottom and the top. And then the bottom will be my 6x, and the top will be 2x. Again, once you have that common denominator, you keep it, and you do whatever operator is required. And this is subtraction, so I do 15 minus 2x. And this is where you have to be really careful. Those are not like terms on the top, so make sure you don't subtract them. If it was 15x minus 2x, you could subtract them, but that has to be left. Also, don't start mad slashing at things because there's a subtraction, so you can't cancel the 2 with the 6 or the x with an x when you see that subtraction. And there's no factoring that can go on, so that one's completely done. That's very similar, by the way, write this next to that problem, to number 1 on the worksheet you're going to get next. I'm taking ones that are really similar to the ones on the worksheet so you have something to look at. So example number 2 is very similar to number 2 on your worksheet. So if you get it wrong, I'm going to tell you, go look at example 2. So make sure you take some good notes here. This is a difficult section. I'm proud of you guys for making it this far. We have 3 over, actually I'm going to cancel that. We're going to do 4 over 2x plus 8. The one on your worksheet is 3 over 2x plus 8, I think. So I'm just going to tweak it a little bit. And then we're going to do 3. Sorry, got to make up my mind. I'm trying to change one that's on the worksheet on the fly here. The bottom I'm going to make it 4x plus 16. All right, so in order for me to make sure my LCD has every single factor, I need to factor them. So go and point at these right here. So when you get to the worksheet, I'm going to say I told you in the notes that you have to factor the bottom first. There was nothing to factor up in example number 1, but this one on the bottom here, I can pull a 2 out, and I need to do that. So I need to factor or pull out a 2 on that one. And then on the bottom of this one, I'm going to factor or pull out a 4. Now, before I can add them, because the denominators are different, I need an LCD. My LCD has to contain an x plus 4. Doesn't need 2 of them, it just needs 1 of them. And some number that will contain both a 4 and a 2, which means the smallest thing that will contain both of those is a 4. So my LCD is 4 times x plus 4. You might say, I don't get that. Why does that work? Because it contains this and this. You want the smallest thing that contains every factor. Does this have a 2 in it? Yes. Does it have an x plus 4 in it? Yes. Does it have a 4 in it? Yes. Does it have an x plus 4 in it? Yes. The minute you answer yes to everything, you found a common denominator. And the least common is the smallest one that you can do that with. All right, so now what I need to do is write this with my common denominator, 4 times an x plus 4. Now I have to go give it what it doesn't have. It has the x plus 4, but it doesn't have 4, it only has a 2. What that means is I need to double and double. It'll give me a top of 8. For the next one, it has the x plus 4, so I'm golden, and it also has the 4. What that means is don't mess with it. It's got everything it needs, so it does not need to get built up at all. It's as good as it needs to be. Now, once I have that common denominator, as ugly as it might be, I always keep it, and I do what it says on the top. I do 8 plus 3. And then I look for any canceling. Does 11 cancel with 4? No. But if that was a 12, it would, and then I'd have to cancel. I'm completely done. So you notice these get a little tricky. One of the harder things you're going to do in this class, actually. Next one up, I'm on example 3, and I have 5 of them. This one is very similar to number 4 on your worksheet. So if you get stuck on number 4, I will go send you to this example. 1 over x plus 3 plus 5 over x squared plus 4x plus 3. So my first goal is I have to figure out what my common denominator is because those are not the same. This doesn't factor, but this does. So I need to factor that bottom right hand. So the first one I'm just going to leave undone. I have to see the factors before I can try to find common ones. So I can break that into 3 and 1. All of it's positive, so be x plus 3, x plus 1. Now that I have it all factored, it's time to find the LCD. It must contain everything. It has to have an x plus 3 in it. Check. It has to have an x plus 3 in it. I already got it. And it has to have an x plus 1 in it. Check. I've now found my LCD. I need to write them both over it. So this one right here, I have to put over x plus 3 times x plus 1. Well, it has the x plus 3. It just needs the x plus 1. And don't go canceling those off because we're going to add it up. So you'll go full circle if you now slash this with this. You'll just go right back to this one. We're pumping it up, not breaking it down. So the next one with my LCD doesn't need to be changed. It has everything it needs, so the 5 stays right here. Now that I have a common denominator, I keep it. And I do the operation that's indicated, which is to add. So I do x plus 1 plus 5. I have a pair of like terms here. So I'm going to call that x plus 6 over x plus 3 times x plus 1. Whoopsie. Now I can't cancel anything because of the addition and subtraction. I can only cancel x plus 6 with an entire x plus 6. They are glued together with that addition sign. So you can't cancel this with this. They're glued with different pieces. They're entirely different. 2 more examples for this section and I will be done. Example 4 is like number 7 on your worksheet. 8x, sorry, I have a cold, 8x over x minus 10 plus 5 over x minus 10. Well, this one's really easy because it has an LCD. So I don't need to fart around with it. It's like I said, what's 1/7 plus 3/7? And you say 4/7. Well, this one, I keep the bottom because it's already a common denominator, and I do what it says on the top. I cannot combine these because they aren't x's. I can't cancel anything because of the glue with that plus and that minus. I can't cancel parts of things that are glued together. Last one up, example number 5, which will be on your worksheet like number 8. And there are only 8 on that next worksheet. So I've done 5 of them, like 5 on that worksheet. So you shouldn't have any problem, but make sure you keep these notes out and use them. This is a very difficult section. So I'm going to do 4x minus 3 over x squared plus 8x plus 7 plus 2 over x plus 1. First thing I do is my eyes go right to the bottom of the fractions and I notice that they're different. I know I'm in search of an LCD. I need to look for factors so my LCD can contain all the factors. So I have to factor this one. This one's done. So going on the bottom of that, what multiplies to equal 7? That adds up to 8. And obviously 7 and 1 should pop into your head. So I keep, here, I'm just going to rewrite it in factored form. So the bottom will be x plus 7 times x plus 1 plus 2 over x plus 1. Now I'm in search of my LCD. It must contain every single factor. All right, so my LCD has to have all of this. It has to have an x plus 7 and it has to have an x plus 1. Then I go to the other denominator and I note I already have it, so I don't need to put it on there. If that had been an x plus 2, I've got to throw that on there as well. But this contains x plus 1. So my LCD is the denominator of this fraction. So that one gets written exactly as you see it. I don't need to give it anything. It's got all it needs. But this other one over here is missing the x plus 7. So I'm really multiplying top and bottom by an x plus 7. These take a while to write out. All right, so what do I have on the top here? I need to multiply this by x plus 7. So I'm going to have a 2x when I distribute it in their hippity-hoppity distributive property, right? So then all I need to do is keep the bottom and add up the tops. I'm almost done. So I've got the bottom and I'm going to add up the tops. I have 4x and 2x giving me 7x. I have negative 3 plus 14 giving me an 11. And I'm done. Have a good one. Your next worksheet is number 12, and it is